estimation of the amount of Fe+2 by potentiometry. Aim: to estimate the amount of ferrous iron in the given sample with the standard potassium permanganate by potentiometry. Apparatus: potentiometer, burette, calomel electrode, platinum electrode, glass rod, bakers. Chemicals required: potassium permanganate 0,1 N, ferrous sulfate solution, concentrated H2SO4, distilled water. An electrode dipped in a solution containing an ion with respect to which the electrode is reversible is called the reference electrode, since its potential indicates the presence and concentration of the ions. However, since the potential of the electrode is a logarithmic function of the concentration of ion, it is not possible to find out accurately the concentration of the ion knowing potential of the half element. This is true for very dilute solution where concentrations may be taken as equal to activities. If, however, the ions are removed by the addition of a suitable titrant, the EMF changes first slowly and then more steeply as a fraction of the ion removed increases with the incremental addition of the titrant. Beyond the endpoint of the titration of the ion removed increases less and less. So a plot of EMF of half element against volume of titrant added gives characteristics curves showing step fall or rise in the potential at the point of equivalence. Endpoint is the point of maximum inflection in the graph. In this experiment, the ferrous ion concentration in the given solution can be obtained by titration with standard potassium permanganate by potentiometer. The combination of the stated calomel electrode as a reference electrode and platinum electrode is used as indicator electrode. 10 FeSO4 plus 2 KMnO4 plus 8 H2SO4 gives rise to K2SO4 plus 2 MnSO4 plus 5 Fe2SO4 thrice plus 8 H2O. Procedure: fill the burette with potassium permanganate. Take 25 ml of ferrous solution into a 100 ml beaker. Add 25 ml of 5N H2SO4. Dip the saturated calomel electrode and platinum electrode in ferrous solution. Note the initial EMF. Add 1 or 2 ml of permanganate to the beaker and note the EMF. For our convenience and for better readings, here we are considering a 2 ml of permanganate. After each addition of potassium permanganate of 2 ml. Measure the EMF of the cell. Like that, take the readings for each addition of 2 ml of potassium permanganate and note down the values of EMF. From the values of EMF, find the value of change in voltage, change in EMF, that is delta E.
Now the experiment is estimation of ferrous by potentiometer. That is the experiment. For that experiment, estimation of ferrous by potentiometer, the apparatus required are potentiometer, digital potentiometer, next electrodes. The two electrodes are, the first one is platinum electrode and the second one is calomel electrode. These are the two electrodes which are dipped in this distilled water. These two electrodes are connected to the digital potentiometer like this. Now the other apparatus required are burette stand, beaker, measuring jar and other beakers with solutions. And the chemicals required are ferrous sulfate solution, sulfuric acid, that is H2SO4, and potassium permanganate. The formula is KMnO4, potassium permanganate, which is called base reagent, which is this pink color reagent. Okay, these are the three chemicals required for the experiment. Now first we have to start by filling KMnO4 in the burette. We have to fill KMnO4 up to 0. We have to measure 25 ml of ferrous sulfate by using a measuring jar. This is the measuring jar which is 25 ml. That 25 ml we have to measure and transfer it into a beaker. Next we have to add sulfuric acid, dilute sulfuric acid, that is also 25 ml. We have to measure 25 ml of sulfuric acid by using a measuring jar of 25 ml. We have to take 25 ml of H2SO4, that is sulfuric acid, and fill into the same ferrous sulfate beaker. So now we have 25 ml H2SO4 and 25 ml of ferrous sulfate. These two we have to take in the same beaker and we have to fill KMnO4 into the burette. Now by taking the two electrodes, platinum electrode and calomel electrode, these two electrodes we have to take from the distilled water and we have to place in the ferrous sulfate solution. Okay. So by placing the two electrodes in the ferrous sulfate solution, we have to note down the readings from the digital potentiometer. Placing the two electrodes in the ferrous sulfate solution, we have to note down the reading of EMF from the digital potentiometer. Okay, here the value is 0.33. That value you have to note down in the tabular form. That is the initial reading of the EMF, 0.332. At 0 ml of KMnO4, we are noting down that EMF value. Next, we have to add 2 ml of KMnO4 from the burette into the ferrous sulfate solution from 0 to 2. Up to 2 ml, we have to add KMnO4 into the ferrous sulfate beaker. We have to slightly dissolve with electrodes and again note down the EMF value. You will observe a change in the EMF due to change in potential values. Again we have to add 2 ml of ferrous sulfate, now from 2 ml to 4 ml from the burette. Like that, adding 2 ml of ferrous sulfate into this. From the burette, KMnO4 2 ml is added into ferrous sulfate, and note down the reading of EMF from the potentiometer. Now this is again changed to 0.34. So by adding KMnO4 from the burette, you will observe slightly EMF values will increases slowly. By adding KMnO4 from the burette, EMF values will increase. Again 2 ml we have to add. Again note down the EMF value. 0.399400. Similarly, note down the EMF values by adding 2 ml of KMnO4 from the burette each time, and note down the EMF values continuously. By adding 2 ml each time, note down the EMF values. Like that, you have to add 2 ml of KMnO4 from the burette into FeSO4 solution. You have to note down the EMF readings. You will observe a increase in the EMF values. So at certain point in the middle, you will observe a sudden increase in the EMF value. That sudden increase in the EMF value will be your end point. That end point you have to note down, and you have to calculate the normality. So these are the EMF values we are note down from the experiment. So we will observe a slight increase initially, and in between we will observe a sudden increase from 0.57 to 0.85. A sudden increase you will observe. That value will be your end point. By using these EMF values and volume of KMnO4 values, we have to draw a first graph. The first graph will be the volume of KMnO4 on the x-axis and EMF readings on the y-axis. Okay. Then slowly the values increases. By noting down the EMF values, you observe a slight increase, and then in the middle you will observe a sudden increase. After that also the values will slightly increase. So by joining all these points, at the sudden increase value will be your end point. That value, volume of KMnO4, should be noted down, and that value is confirmed by drawing another graph between volume of KMnO4 on x-axis and delta E by delta V value on y-axis. These delta E by delta V values can be calculated by using this tabular form. Delta E means change in EMF. This change in EMF values are calculated by using, this is, for example, this is E1, this is E2, E3, E4, like that the values will be there. So you will get delta E values by subtracting E2 minus E1. Next value E3 minus E2. Next one E4 minus E3. Like that you will get the delta E values. The same next column is delta V, that is change in volume. Here the volume is, first volume is 0, second volume is 2, third volume is 4. Every time we are adding 2 ml each time. So the change in volumes will be 2 ml each time. By dividing this delta E with delta V values, you will get the delta E by delta V values. These values you have to plot in the second graph by taking volume of KMnO4 on the x-axis and delta E by delta V values on the y-axis. So you will observe a graph with slight increase and then a sudden increase and then decreases. So if you join all these points, you will get a peak like graph. This value, the peak value, will be your end point. This value here, the volume of KMnO4 is x. The same value should be match with the first graph, volume of KMnO4. So this x value, if both the graphs the value matches, your value will be correct. That volume of KMnO4 from the both the graphs, you have to substitute in the formula N1 V1 equal to N2 V2. Here N1 is normality of KMnO4. Next V1 is volume of KMnO4. N2 is normality of ferrous sulfate. V2 is volume of ferrous sulfate solution. Okay. So by substituting the values, you have to find out the normality of ferrous sulfate N2 value. So N2 value will becomes N1 V1 by V2. So here N1, normality of KMnO4, it is a standard value, that is 0.01. V1 is volume of KMnO4, what we got from the graph. That value you have to substitute, that is x value, divided by volume of ferrous. How much ferrous sulfate you have taken in the experiment? That is 25 ml. We have taken 25 ml of ferrous sulfate, substitute 25 ml. So by substituting x value in this formula, we will get the normality of ferrous sulfate.
Value of N2 is equals to 4 into 10 power minus 3 N, and the amount of FeSO4 present in 1 liter equals to N2 into 55.85. Therefore, we can obtain the value of amount of FeSO4 present in 1 liter equals to 0.2234 gram per liter. Result: normality of given ferrous sample equals to 4 into 10 power minus 3 N, and amount of ferrous iron present in the given sample is equals to 0.2234 gram per liter. Thank you for watching. Please like, share and subscribe if you like.